Hi, welcome back to Chem with Go. This is Mr. Go, and tonight we're going to take a look at organic reactions and specifically substitution. Note that for this specific organic reaction, this will focus on alkanes and hydrogens being substituted within the alkanes, or in this case, benzene rings. So we'll focus on these two. Note that what happens in substitution is that a hydrogen is replaced, and in this case we're going to replace it with a halogen, so it becomes, the whole molecule becomes an alkyl halide. So we'll first focus on long chain alkanes, and then we'll take a look at an example where we have a benzene structure and being substituted with, one of the hydrogens being substituted with a halogen. So first, let's take a look at just a simple molecule like ethane. And those extra marks right there will be for the hydrogens. Now, if this happens to react with chlorine, and chlorine is one of the diatomic gases in the periodic table, this chlorine, will substitute into this position. This hydrogen will trade places with this specific chlorine right here. And the eventual result, you get this. 2 carbons, instead of this being a hydrogen, now I have chlorine attached to it right here. And the byproduct will obviously be H bonded to the Cl. So hydrogen chloride gas. So substitutions are for alkanes, again, and for benzene rings. Let's take a look at another example. What if we had something like this? And I'll do it shorthand. So this right here is butane. And if I reacted this with iodine, and iodine is another diatomic molecule like this. Oops, so I forget the 2 right there. And there we go. So what forms with iodine gas reacting with butane? Well, I could get this, where this N carbon has iodine attached to it, and the name of this compound would be iodobutane. Now we do have to make sure that we go ahead and indicate that iodine is on the first carbon, since there are different possible combinations or different possible locations where the iodine could be. Now, iodine could attach itself or substitute with one of the hydrogens on the N carbon right here to make 1-iodobutane, but that's not the only place that it can actually add to. It is possible for this iodine to attach itself to one of the internal carbons right here, and if that's the case, then I got this structure with an iodine right here down at the bottom. And since this is now on the second carbon, this will be 2-iodobutane. Alright, so the only other example that we have is for benzene structures. Now, the way benzene structures work is, since each carbon only has one hydrogen that's attached to it, the substitution will be to one of those hydrogens. Again, if I have a benzene structure, each one of those marks is a hydrogen right here. Hydrogen, hydrogen, and then a hydrogen right there. And if this was to react with fluorine gas, what happens is one of the fluorines will substitute itself into there, so then I get this structure. Plus HF, or hydrogen fluoride gas. Alright, so that's a simple organic reaction. Again, we're taking a look at substitution in alkanes and benzene rings. In the next lesson, we'll take a look at the other sort of major organic reactions like addition, condensation, and elimination. All right, we'll see you again soon.